All right, so how do we do these two problems?
Put in your calculator.
Yeah, just put in your calculator,
I
right?
don't have a calculator.
That's something that should not be. So to the second and to the third, right?
True that.
That's all you got to do, right?
I can't do it because I have no calculator. It's a straight line. It's a straight line on the bottom.
All right, so all we're doing is putting that in the calculator, right? Why doesn't it work?
They're parallel. Because the line is parallel. I'm just. You copycat.
That's all it is, right?
You're going to.
It says evaluate each expression, right?
Why wouldn't it be?
Oh, I put 2, didn't I? Sorry. Well, this is supposed to be 3, right? All right, let me do that one first, since I got a positive here. Oops, that's not what I wanted to do. So, oops. All right, so there's to the third power, 5.46. And then to the negative second power, I have to do that, and it's 4.71. I don't understand what the problem was. Right? Just too easy? It's just calculator work, right?
That's all you do.
Yeah, that's all you gotta do when you evaluate, right?
That is all you do. That's all
All right.
you do.
So, for number 4, you had to do that, and number 6, right?
Yeah.
All right, let's see what you're supposed to have gotten. Number 4, the answer is 24 for negative 2 as the exponent, and 3/4 when you put 3 in there. And for number 6, when you put negative 2 in for x, you get negative 3.125. And for the cube, when you cube it, it's negative 1.024. Again, just put it in your calculator, right? So, number 12, growth or decay? Decay, why?
The first two are decay, and then it goes to roll.
Yeah, the first 2 are decay because
Because they're less than
these
one.
bases are less than 1, right? Between 0 and 1, right? Those 2.
Correct.
And then number 16 is growth because the base is bigger than 1, right? And, you know, a quick sketch of those. First 2, if decay, it looks something like that, right? And we can just I'll show you how to put it in the calculator again. And the growth ones, excuse me, look something like this, right? They all look pretty much the same. Okay, use your calculator. Remember when you graph something, do your y equals. All right, so 2/5, put it in parentheses just like that, 2 divided by 5, caret x. And hit graph. Oh, I have it in the first quadrant. I have to change my window. How do I get to the normal window? Zoom 6, right? Zoom 6. There it is. Okay. If we change to 0.75 here, and graph it, it's a little flatter there. Okay. the growth one, 1.8 to the x. Okay? So, again, if you don't have a graphing calculator to do those, you can make an XY table, right? And just use your regular calculator to find your Y answers and then plot them, right? I would just use -1, -2, -2, -1, 0, 1, and 2 for my XY table and go from there. All right? So there should not be any excuse, AJ, for not graphing them.
I don't have a calculator.
Any calculator will work.
XY table. Put them in your regular.
You have your phone?
You have a phone, don't you?
You have a phone? You have a phone. Does it have a calculator on your phone? Then you got a calculator. Okay? All right? Again, AJ, listen, all you got to do is make an XY table and just use those numbers for X. Okay? Then you get 5 points to get an idea what it looks like. All right? So we don't really need our graphic calculator to do it. It just helps us do it a lot quicker, right? All right. So let's look at this problem. All right, so it says the value of a mountain bike, Y in dollars, can be approximated by this model. So we're looking at this equation, right? T is the number of years since the bike was purchased. Is that growth or decay? Why is it decay again? Right, the 0.65 is what we look at. All right, that's between 0 and 1. All right, it says identify the annual percentage increase or decrease. All right, so you just go 1 minus 0.65 to figure that out, which is what, 0.35? So what percent is that? 35%. Again, that's a decrease because it's a decay problem, right?
Yeah.
All making sense so far? William, wake up. No, you're not. Your eyes are open, but you're not here. Okay? So come back to us, all right? Estimate when the value of the bike will be $50. Okay? So, what we say is the easiest way to do that? What did we say yesterday? Nobody remembers.
The easiest way to
Just find that answer. Calculator, right? What do I punch in? Equation where? Yeah, but where do I punch it in? My y equals, right? Okay? So we go 200. What's 200 telling me?
That's your Y.
Starting amount, right? So the mountain bike, you pay how much for it? $200. Okay? So 200.65 to the x. Now, what did I tell you to look at to figure this out?
So you put 50 in for what your 200 is.
Well, we're looking for when y is 50, right?
Oh, yeah.
Where can I look for that? I can do the intersection, right? That's what you were saying, right, Kelly?
Yeah.
Okay. We could do the y equals 50, but if I keep it in my Zoom 6 form, I won't see the y equals 50. Might not even see the other one. All right. Why won't I see the y equals 50? What's the highest y that you can see right now? 10, right? So you got to change your window. All right. Window is that window button next to y equals. Again, this type of problem, we're just really worried about the first quadrant, right? So make your x min 0, and let's make your x max. It started out as 200, so we'll just go 200. All right. because that's how much it was when we started, right? And then we can keep our scale at 1, we can go by 2s, we can go by 5s, 10s, it doesn't matter. Let's just keep it at 1. Y min will start at 0 also. All right. And Y max, let's go up to 100. And we'll go by 1s again. Wow, we can't see that very well either. Let's not go by 1s. Let's go by 5s for both.
I'll think it's more.
Okay, that'd be okay too. Now still, you can't see your decay graph very well. All right, but we can see our y equals 50 line. All right, so how do I get the intersection? Do you guys remember?
You have to hit that line trace.
Close. Second trace.
Second trace.
Thanks, Vin. Second trace, number 5. And just hit enter 3 times. All right, so 3.2 years, it'll be worth $50.
That's a lot.
All right, what was the other way you could have done instead of graphing it? Go to second graph, the table, right? And you want to see when there's 54 at 3 years, right? So somewhere between 3 and 4 years, it goes from $54 to $35. Okay? Looking at the table. So either way is fine. Okay, like I said, we'll learn how to solve those equations in when we get back from break. All right. Number 20, the answers are, it's an exponential growth. It increases 1%, and it takes about 6.2 years to get to 30 million people. All right. 26. It says the number Y of salmonella eggs on an egg after T minutes is this equation. So, using that T over 45, using the T over 45 exponent is kind of a pain, all right? So, a better way to do this is break that fraction up as to 1/45th and then to the T. All right? So changing that 4.7. So Mason, put 4.7 to the 1/45th power in your calculator for me, please. And tell me that number. What'd you get? 40.7 to the 1/45th power. No, just put in your calculator. Get out of the graph. Just put 4.7 caret and then parentheses 1 divided by 45.
Weapon. How'd you bring me to school?
1.034.
Make it look like a solid wood.
Actually, if I go, it was 349, right? So now we can tell if it's growth or decay. All right? What's happening? Growth, right? That makes sense, right? Look at the problem. It's talking about salmonella eggs growing, right? Increases, right? So it's a growth problem. So when you get a problem like this, where you have t over something as an exponent, make your exponent 1/45th, whatever it is, change it to the, so it looks like what you're used to doing. Does that make sense?
Yeah.
Okay? And it says by what percent does it increase each minute? Okay? So move that decimal point over to, so 3.5%, it's increasing per minute. And that's all we had to figure out, right?
Yeah.
So doing this, splitting this up into 1/45th exponent helps you figure out the percent increase or decrease that happens.
I'll give this one 5.
It was 4.7. So I just put that in the calculator, 4.7 to the 1/45 power. Oops, I don't need that extra one, do I? All right, so that's why we got that 1.035. Okay, it was 4.9, so I rounded it. Okay? So that's what you're going to have to do when you see stuff like that. Why are we not what? Well, when it's an increase, remember, we did the 1 plus R stuff yesterday, and a decrease, we did the 1 minus R stuff. Okay? So if you wanted to split that up into 1 plus 0.035, you could. That's a good question. All right, so today, adding on to what we did yesterday, this is called exponential growth and decay still. We're going to talk about compound interest today. Caleb, quit acting so weird. All right?
It's gonna be hard. Thank you. You have no voice. That's what he's talking about.
That's what I'm talking about. Your voice is way too loud right now, okay? All right, compound interest, all right, is interest paid on an initial investment called the principal. So your initial amount you start with is called the principal, and previously earned interest. Interest earned is often expressed as an annual percent, but the interest is usually compounded more than once per year. So the exponential growth model must be modified. So here's our exponential growth model we talked about yesterday. Decay was a minus, all right? So we're going to use this equation today for compound interest. The capital A represents the total amount after so many years, okay? The P represents the initial amount we start with. R is still a decimal like yesterday. That's that percentage rate. We'll move that decimal point to the left, just like yesterday. N represents how many times it's compounded per year, and then T represents the number of years, okay? So sometimes when they say compounded yearly, N is 1. If they say compounded monthly, what's N? N is 12, right? If they say compounded quarterly, N is 4. And sometimes they'll say compounded daily, N would be 365. And remember, it says NT here, right? NT means what? Correct. N times T. All right? So if it's daily for 2 years, that's 365 times 2. Okay? If it's monthly for 2 years, it's 12 times 2, 24. Okay? So remember, the NT means N times T when you plug it in. Okay. All right, so it says you deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. All right, so again, we use this formula. A equals P times the quantity 1 plus R over N to the N times T power. All right, make sure I remembered that right. All right, 1 plus R over N to the NT power. Okay, so what's my P? What's the P? P is a percent, P is principal. It's the $9,000. It's how much you start with, right? The R is your interest rate. That's the percent. How do I write the R? 0.0146, right? Everyone okay with that?
Yeah.
It said compounded quarterly, that's what N is, so N is what? 4. And then N times how many years? 3. Which I would just make a 12. You guys know what 4 times 3 is, right? So just put that in your calculator, and that's how much you have after 3 years. Okay? So 9,000 times 1 plus, I always put it in an extra parentheses there, 0.0146 divided by 4, caret 12 power. Okay? $9,402.21. So go to hundreds, go to the nearest cent when we're talking about money. Questions? So all it is plugging into the formula, right? All right. Questions? What do I put in for P? 500. What do I put in for R? 0.025. Remember, 2 places to the left. It's compounded daily. So what's N? 365. And then 365 times 2 goes there. All right? Questions? Pretty easy, right? They give us a formula, we just use the formula. Okay? Cole, you okay?
Yeah.
All right. Not worried about the answer. I'm just worried about you putting in the right numbers. Good? All right. It says rewrite the function in the form y equals a times the quantity 1 plus r to the t power, or a equals 1 minus r to the t power. State the growth or decay rate and describe the end behavior of the function. Okay? So, we got this t over 3. So, it's like number 26 on our homework. We want to rewrite this as t2 to the 1/3 to the t. So I want to change that 2 to the 1/3 to whatever that is, so I can tell what's going on. So go back to my calculator and do 2 to the 1/3 power. So you have to put, in my calculator, you have to put parentheses around it. Some of you don't have to do that parenthesis part. So 1.2599 is what I get. So how do I write this? Do I write it as 1 plus R or 1 minus R? Plus, because it's over 1, right? If it was just 0.2599, then I have to write 1 minus whatever, okay? All right, so my answer this okay? All right, so it says state the growth or decay rate. All right, so what's the growth rate? Not graph, but growth, right? Is 25.99, or we could say 26%, right? Does that make sense?
Yeah.
I broke it up as 1 plus. The directions told us to write it as 1 plus R or 1 minus, so that's why we broke it up. And then this is our growth rate. If it's plus, if it was minus, it'd be our decay rate. Make sense? Now, it says something else up here. End behavior. Okay? End behavior is at the end of both graphs. It's a growth graph, right? So all growth graphs have basically this look to them, right? So what's the end behavior of this graph? What's happening over here? So x goes towards infinity. What's the y doing? What's y going to? As x goes towards positive infinity, I guess. What's y doing? Is it going? Going up, aren't I?
Yeah.
Remember down here is positive infinity, right? So what's it doing? It's going to positive infinity, right? As x goes towards negative infinity, what's the y going to? What's it getting closer to?
The line.
That line, right? What is that line? What's the y value? 0, right? That's what they mean by end behavior. What's happening as x approaches positive infinity and as x approaches negative infinity? That's what it's asking. And it says end behavior. Okay? One more. Let's look at one more, then we'll have homework. All right, so this one, we're going to go A and then 0.25. And you guys should be able to tell me if it's growth or decay. I thought I heard somebody said decay, right?
That was right here.
That was AJ, right? All right. So what is 0.25 to the 1/9 power? All right. So 0.25 to the 1 divided by 9. All right. So it's 0.857. 0.8572. All right, so how do I write that as a 1 minus? But not that. 1 minus what is that?
Oh, then you subtract that. Would you? Then you use that answer and subtract.
Right, so I have to do 1 minus that, right? To find out what that is. Is. What was it? 0.1427. 5, so 0.1428. All right, so what's the rate of decrease? 14.28%. Right? Okay. Making sense? Okay. So, sometimes if it's not 1 point something, like this one, we got to subtract that number from 1 to figure out that percentage of decrease. All right? Okay, so don't forget that last step. Now you can have some homework. And there's 3 problems from your book. Nolan, did you help Jordan out on that book? Did it work?
Yeah, no, she was just putting on the Spanish. There's 2 books, one on the Spanish.
I know. That's what I thought.
That's embarrassing like that though, too.
And we lost it.
We're just making sure you're okay, Jordan.
No,
Okay.
not now.
Both sides too. He's looking at his phone all period. There's 2 there. You don't have to do number 9 unless you want. Want to be challenged a little bit.
Rather you talk about